All right, let's get started. So the TA is working very hard to grade the exam. It's easy to grade the multiple choice answers. It's just the machine that does that, but it will take a while to grade the answers to the short answer questions. So hopefully by next week, someday next week, we'll have some results. And I think we'll send you the raw score for the exam and a rough indication of what that would mean if we would apply a curve. That doesn't mean that that will be the very curve that we'll use at the end, but it would give a rough indication so that you roughly know where you are. So is there any question about the exam? Yes?
Will you be posting the multiple choice results beforehand or not?
Well, I think it's just every question is 1 point. If does that answer your question?
No, I'm asking if, you know how we have the multiple choice and then there's the written part?
Yes.
Will you be posting like, okay, this is how we did for the multiple choice?
I assume we can break that down. If we can, we'll try. But I'll have to see how the TA will input this into the system. Yeah, so hopefully we can. But I won't make any promises. Yeah? Any other questions? All right. So this is the last part on learning before we go on to thinking. So last time we talked about habituation and classical conditioning. And today we'll move to some of the more powerful forms of learning. Instrumental conditioning, also known as operant conditioning, and observational learning. So we talked in the classical conditioning paradigm a lot about involuntary reflexes. How can you learn to evoke a reflex such as an eye blink or a salivation response? And clearly classical conditioning shows some interesting learning there, but this can't be the full story of learning, right? So there's a lot of things we learn that don't involve any involuntary responses. So how do we learn about things that are more under our control? So Thorndike, he was very interested in giving explanations of general learning. And he proposed the law of effect. And it's an extremely simple law or rule. If a response, some behavior that's under your control, if that's not rewarded, it will be weakened. You tend to exhibit that behavior less over time. But if a response, a particular response or behavior, if that does lead to a reward of some kind, and we'll talk about the types of rewards, it will be strengthened. Now this is extremely simple, but this is a big theory in psychology, and it has led to many successful explanations of learning. So let's see, I will show you some short video that describes Thorndike's puzzle box. Let's see if this video works.
But how is a new skill learned? That was a question which began to fascinate Thorndike. To answer it, he built some ingenious puzzle boxes from which cats could only escape by operating latches.
And there you go.
The cat appears to be very clever in engineering its escape, solving the problem with a deftly placed paw and a push of its nose. But Thorndike didn't believe that an animal, even a clever cat, understands to measure the rate of learning.
Right. So here are Thorndike's results, where he plotted the time of escape, how long it takes for the cat to escape this little puzzle box, as a function of the number of trials that this cat was placed in the box. And so he found this gradual learning effect over time. So it looks, it's not exactly a smooth curve, but over time, the cat takes less and less time to figure out what response is needed to escape this box. And it depends how you set up the puzzle box. Sometimes they have to pull on some string in order to open a door, which is a non-intuitive thing for a cat to figure out. Now, Thorndike's claim is that there's no insight used during this process of learning. The cat didn't really see the solution all of a sudden. And there's some controversy about whether animals can or cannot use insight during problem solving. Certainly Thorndike did not believe in the process of insight. He believed that there was a very simple rule that governed learning here that can be described as the law of effect. And here you see a diagram that explains this, this process in action. So for the very first trial that the cat is placed in this box, there's some natural tendencies, some natural responses of the cat in this situation. So cats naturally bite, jump up and down, they might meow, and it's not very natural to pull at the string at first. All right, so there's some randomness associated with these responses initially. Now, just by chance, the cat might just grab at the string, pull at the string, and that might lead to a successful escape. And because that leads to a successful escape and the cat is rewarded for that, that association between the pull at the string and the reward that is strengthened. So over time, those associations are strengthened. There are more natural responses in this situation. Those are weakened, so that over time the cat more quickly evokes this, this response to pull at the string. And so no insight is used here. There's no fancy learning going on. It's just a simple association between a response and a reward. And that's called instrumental learning. A person or an animal figures out the response that is instrumental to the outcome. Now, B.F. Skinner, he's arguably the most important researcher when it comes to learning, certainly in the 20th century. And he built on this research by Thorndike. So Skinner did this research, decades after Thorndike's research. And he was the first to make some real distinctions between classical conditioning and what he called operant conditioning. And operant conditioning is just another word for instrumental conditioning. So in his paradigm, he placed animals inside a little box, and he studied animals in conditions where their responses are a bit more natural, like pressing a lever or pecking. And then they had to sort of press a lever or do something at the right time under the right conditions. And then he studied this process of learning over time. So here's a little example video that with pigeons that explains operant conditioning. Oops.
In the early 1940s, Skinner began to examine a simple response of an ordinary animal. A pigeon pecking a disc that was followed by a reinforcer, say a food pellet or some water. A reinforcer is anything that increases the rate of responding. The pigeon was kept in a highly controlled environment that's come to be known as a Skinner box. And Skinner's version of instrumental conditioning is known as operant conditioning.
Well, operant behavior is behavior which operates upon the environment and produces consequences. And operant conditioning is a change that takes place when those consequences have a particular effect. And we call the effect strengthening or reinforcing.
Through operant conditioning, pigeons have been trained to peck at the correct sum of numbers and to perform all kinds of feats.
Right. So Skinner made this distinction, very important distinction, between classical conditioning and operant conditioning. So in classical conditioning, the response is elicited by an unconditioned stimulus and a conditioned stimulus. We're talking here about involuntary responses, reflexes essentially, that according to Skinner have no effect on the external environment. Right? So a salivation response, that's just an internal response. You're not acting on the environment. And the association learned is between the CS and the US. On the other hand, operant conditioning, a response is emitted. It's more under your control, the person's control or the animal's control. And Skinner refers to this response as an operant, because it can operate on the environment. It can have some consequence for the environment. Also, the association learned here is between the response and the reinforcement. So there's some differences between these two paradigms, and that said, there's a lot of overlap. So many of the phenomena that we talked about, generalization, blocking, contingency, all those things that things that apply to classical conditioning, they also apply to operant conditioning. So one of the amazing things is that animals, they use these very simple learning mechanisms to learn which, under what conditions to evoke a certain response. And that can lead animals to display behavior that seems quite intelligent, but it's just based on simple discrimination learning. When some responses are reinforced and others are not, the animal will really have an incentive to learn that discrimination. And they can learn very powerful discriminations that seem intelligent, but it's just based on very simple learning processes. So here's an example that Skinner gives of seemingly intelligent behavior, and then he starts talking about reinforcement learning schedules.
Can pigeons read? This one gives every indication, because it's been taught to distinguish between two words and to behave appropriately. He's learned his different response to each sign by being rewarded with food. So the bird isn't acting independently. Its behavior is shaped by controlling its environment. The first task was to isolate an individual piece of behavior and see how fast it could change. Skinner did this by keeping individual pigeons about 3/4 of their normal weight, so that the birds were always hungry, and food could be used as an automatic reward. The pigeon was studied in a uniform box when it quickly grew used to it. One piece of behavior, pecking a coloured disc, was measured on a graph. The pigeon learned that pecking the disc produced a reward. Then the behaviour of pecking could be studied in relation to how often that reward was offered. When Skinner's turn, what was the schedule of reinforcement?
The main thing is what we call scheduled reinforcement. Reinforcement is what we call reward, and you can schedule it so that the reward occurs every now and then when a pigeon does something. We usually use a response to pigeon pecking a little disc, a spot on the wall, and you can reinforce with food, but you don't reinforce every time. Perhaps every 10th time, or perhaps only once every minute, or something like that. There are a very large number of schedules, and they have their special effects.
Okay, so a very simple thing to do is to deliver the reward whenever a response is emitted that's desirable or of interest, let's say. But as Skinner was mentioning, there are many ways to schedule the reward. You don't have to give it all the time. Learning can be successful if only occasionally or part of the time you deliver the reward. And how you deliver the reward contingents on the response. That can have some consequences for how quickly you learn. So one way to deliver the reward is based on an interval schedule. So one way is just have a fixed amount of time elapse before the next reward can be delivered. Note that in a fixed interval schedule, the animal still has to do something. There still needs to be a peck. But if the peck is given at the right time, then after this fixed interval, the reward will be delivered. For example, in the real world, you might think of people that receive bonuses every year, sort of a fixed schedule. You have to do something, let's say, to receive this bonus, but you get it every year. Now, on the other hand, if you have a variable interval schedule, then it's unpredictable exactly when the potential for reward arises. Again, you still have to do something to get the reward. And so on average, it might be after 1 hour or 1 year or some average amount of time, and sometimes it arrives more quickly than other times. For example, with radio reward programs, they might give away free tickets after an hour, but it might also if you call in the right time, it might happen after half an hour or 2 hours, whatever. So this unpredictability has consequences for learning. Learning is actually more regular under variable interval schedules. People learn more effectively when the rewards are delivered at unpredictable intervals. Under fixed interval conditions, people will learn to evoke the response right before the interval will start again. And so you see a very variable amount of learning or responses under fixed interval conditions. Now, a ratio schedule is very different. Here it doesn't depend on time or how much time has elapsed. It depends on the number of responses that are evoked. So the simple schedule is a fixed ratio schedule. The reinforcement is presented after a fixed number of responses. Think about a rewards card. You get a free meal after you go to a restaurant 5 times, let's say. On the other hand, a variable ratio schedule, here again there's some unpredictability. You need some number of responses. You don't exactly know how many. Sometimes you need more than others. But on average, you get a reinforcement after a certain average number of responses. And again, this unpredictability in a sort of counterintuitive fashion that actually strengthens learning. People will learn more under a variable ratio schedule. So here's a diagram that shows the differences between these various schedules of reinforcement and also the consequences for learning. So on the vertical axis, you plot the cumulative number of responses. Let's say it's the pigeon pecking to get a reward. And on the horizontal time, you just have elapsed time. Now, under all these schedules, you would just predict curves that just go up, right? Because time goes by and you get you evoke some responses, so you always go up in some direction. But the slope of these curves indicates how quickly you're learning, how many responses you're emitting per some unit time. So steeper slopes indicate you're learning more, or you like to exhibit this behavior more. So one thing you see in this graph is that these ratio schedules have steeper slopes than interval schedules. And that's the general results. If your behavior is rewarded based on how much work you're performing, you will work harder. Now you also see the differences between these fixed and variable intervals, fixed and variable schedules. So if you have a fixed ratio schedule, then the rewards indicated by these little bars here, they're given at sort of fixed numbers of responses. So here in this plot, it's about 150 trials or so, and you get another reinforcement. For the variable ratio schedule, as you can see, there's no clear relationship between how many responses are between each consecutive reinforcement. On the other hand, these fixed interval and variable interval schedules, here it's the amount of time that elapses that determines if a reinforcement is delivered. The other thing you see is that under fixed interval schedule, the rate of learning, or the rate of these responses over time, is not uniform. The person or animal here learns when the reward will become available and will respond more vigorously towards the end or towards the start of this interval. So learning is quite non-uniform. Whereas under variable interval conditions, learning is quite uniform. If you cannot predict when you'll be rewarded, you tend to exhibit whatever behavior will be rewarded eventually more uniformly over time. Does this graph make sense? Any questions about this? Okay, so let's make things a bit more concrete. So let's give some examples. So if you reprimand a child, if you have to ask your child to clean his room 3 times, I changed if you copy the old slides, I used the word spanking before, but spanking is, you shouldn't spank your child. So change it to reprimand. So what kind of schedule is that? Fixed ratio, right? Because you have to, after a fixed number of things, you reward or punish, let's say, right? It turns out to be quite ineffective. For those of you who worked with children, right, every time you count, like, I will do this in 10 seconds if you don't listen to what I say, they will just wait patiently until the count of 9 or 10 and then do the behavior that you're interested in. Quite ineffective. I keep doing it with my own children, actually. If you give a raise every 2 years, what kind of schedule is that? So fixed interval, right? Also somewhat ineffective. People tend to work hard just before that raise is coming or that bonus or whatever it is, and don't work very hard the rest of the time. Playing a lottery game. So that's variable ratio. You have a question?
Can you explain the fixed interval?
What?
Can you explain why it is fixed interval?
Why this is fixed interval? Because you're saying, as long as you perform okay, right, so you have to respond in some desirable fashion, you'll get a raise every 2 years, right? And you know in advance that interval, right? It doesn't mean you automatically get that raise, right? That's important, because that would induce no learning whatsoever. Yeah. So playing a lottery game, that's variable ratio. So whenever you pay money for a lottery, there's some probability of getting some return, so you need to, over time, there's some mean return, but sometimes you win, sometimes you lose, so there's some unpredictability here. Variable ratio reinforcement schedules, it's quite amazing how strong they can be to induce learning. So they can be good or bad. So in terms of lottery games, people think, or this kind of reinforcement is a powerful incentive for people to play games, even though there's actually not much control they have over the outcome. if your boss checks you periodically, but you don't know when she might come in next time, so that would be variable interval, right? Those are also very powerful ways to induce learning. So unpredictability is good. All right. So Skinner presented these very highly simplified learning conditions where the pigeon has a natural tendency to peck, the rat has a natural tendency to press a lever. But how about more complex behaviors that are not so natural to begin with? So these can be trained through a process of shaping. So if you want to train a dog to, let's say, jump up in the air in response to some stimulus, the dog is not going to do this immediately, so you have to first reinforce the behavior that looks roughly right, or might not even be right in some sense, but the dog might be in the right position where you want this behavior to be elicited. And then gradually you reward more or less and less behaviors in order to get the dog to do something desirable. So after 20 minutes of training or so, the dog might be trained to jump up because it's only rewarded at that time when it's jumping up. And you can train animals to do some quite amazing things. So here are two pigeons that learn to play table tennis. And Skinner did this by just gradually reinforcing behaviors that look more and more like gameplay.
The two pigeons are either end of a small ping-pong table. One pigeon pecks the ball as it comes toward him and knocks it toward the other pigeon. The other pigeon pecks the ball back across the table. If it goes past one pigeon, the other pigeon can eat, and if it goes the other way, the other pigeon eats. So there's a real field game. The pigeon is reinforced for a cross-court shot if that is what gets the ball past his opponent.
Right? So pigeons will never do this initially, but will do this if you gradually sort of reward the right kind of behavior, like being near this table or pecking at the ball, and then proceed from there.
Can there be bias where they may want to help the other? I mean, or is it consistent?
Bias in what sense?
In the sense that I know he's going to get food, and maybe if I help him, he'll give me food. If that makes sense. So they know that either way they're going to get food, so maybe they can trade off.
Yeah, so this relates to the concept of altruism, or
sure, or
right?
Or they may. What I'm asking is, can they learn that there's potential for that if they help each other, if they come together and they say, "Hey,
I think there's some controversy about this, whether animals truly understand such a concept. As we'll see later, animals they have some limited ability to reason about others, like what another animal do has consequences for what I do myself, but it's limited. And there's great debates in psychology about what's called theory of mind, the ability to put yourself in the position of another person, right? People can do this, young children cannot, and some people argue animals cannot. Although there's some recent experiments that show that animals can think about others. Yes. Now, another very interesting result that Skinner obtained was that sometimes he observed pigeons doing very strange things. So when he scheduled a reinforcement every 15 seconds or so, then some of the pigeons, they ended up doing very odd things. Like they started picking aimlessly in a corner, they started to walk in circles. And Skinner hypothesized that they might have learned some accidental correlation. So the pigeons were doing something when the reward was delivered. And this could have been, a large number of things. They could have just happened to walk in a circle and then food was delivered. So the pigeon might have learned that maybe that is the reason, or maybe that's the way in which I can get the reward. Because there's so many possible things that you could associate with the reward. Occasionally, you might learn the wrong things. You might learn the wrong association. And Skinner believed that this might explain superstitious behavior in humans. Now, people do some odd things and learn some odd things. In sports, for example, sports players and coaches, they have some very strange superstitious behaviors. Coaches can wear the same clothes to games because at some point they won a major game using a certain set of clothes and they believe that caused them to win. Some sports players, they learned not to take a shower the day of the game because they once won a game not taking a shower, so maybe that's the way to go from now. Think of waiting for an elevator and you press the button. Right? Everybody knows how an elevator button works, but how many of you press that elevator button again? Yes. That doesn't make sense, right? You do it, I do it too, right? This morning I pressed that button for the crosswalk multiple times. And I know better, but this could be just some superstitious behavior where you learned that at the right time if you press it, or just accidentally by pressing it at a certain time, the light changes or the elevator arrives, and maybe from then on you display this behavior again. So by strengthening, by giving rewards, you might strengthen desirable behavior, but occasionally also strengthen behavior that is non-consequential or has no relationship. So one of the keys for learning is, again, this concept of contingency. Contingency was very important in classical conditioning. It's very important in operant conditioning. It's not so important how often reward arrives. What is important is whether there's some relationship between your actions and the rewards. If rewards arrive no matter what you do, you won't learn because there's no contingency. So the book mentions this interesting experiment with infants, where the infant is lying in a crib, and in one condition, the infant could trigger a switch in the pillow, and that switch made this mobile toy spin around. Now, infants, they perceive this as a reward of some kind, so they quickly learn this association between triggering the switch with their head and making this mobile toy move around. So they will do this often in order to elicit this response, or this reward, I should say. Now, if you place another group of infants in conditions where there is no such relationship, there's no switch, but the toy mobile moves around as often as in the other condition, they won't learn anything because they have no control over the situation. There's no contingency. So either when you have control over your situation or you think you have control, that's when learning takes place. A lot of people gamble because they believe they have control over the situation, and often they don't have any control whatsoever. They're just steadily losing money. But it's the belief in control that's important. Now, your belief in control, having control over your environment, can be very important for your mental health. If you place people in a situation where you don't have control, that might have very negative consequences, because it might lead to learned helplessness, a belief that you don't have control in any situation. So Seligman did some amazing experiments, somewhat unethical experiments with dogs. These experiments you can probably not do anymore. So in these experiments consist of two phases. in phase 1, there were 2 groups of dogs. These dogs were in a situation they couldn't escape. Occasionally they were shocked. And one group of dogs could turn off the electric shock by pressing some button or moving their head. I forgot how it works. Another group of dogs, the so-called yoked controls, they were paired with another dog that had control, and they received the same number of shocks at the same times, but the dogs in that second group, they had no control over turning it off. So they received the same number of shocks at the same time, but there was no control for the second group. Now, the important part of the experiment was how these dogs generalized their, whatever it was that they learned, to the second phase of the experiment. So here this was a new situation where the dogs were in this cage. The floor had some electric wires so they could be shocked again. And so they could escape the shock by jumping from one part of this cage to another part of the cage. Now, the important result was that the dogs that had control in the first phase of the experiment, they escaped the electric shock in the second phase of the experiment just by jumping. The dogs that had no control but still received the same number of shocks, they learned a sort of form of learned helplessness. They refused to jump up to the other side because they believed they had no control anymore. They had no control in the first phase, and therefore, in their minds, they had no control over the second phase. And so Seligman drew this parallel to humans being a state of learned helplessness. And he used it to argue that maybe depression is a state of mind where you've learned that nothing what you do has any consequence. You have no control over the environment, and that is the reason why you are depressed. He also used it to explain math phobia. Some of you might refuse to deal with equations and numbers because you believe that you will fail no matter what you do, because you have failed in the past multiple times with numbers and equations. But maybe this was just an unfortunate an accident where you were dealing with material that was just a little bit too hard at that particular time, and you just learned, you were in a state of learned helplessness as a result of that. So one very simple recommendation is never to put people in a situation that they can't control, right? When you teach people math, teach it at the right level of difficulty so that some things are solvable, so that they are never in a state of learned helplessness. Okay, so there are several types of reinforcements we can think of. The basic reinforcements, the ones that work very well, they serve some biological need. Food, water, warmth. For obvious reasons, these work very well. But secondary reinforcements, they're quite powerful as well. Money, tokens, grades, anything that can be associated indirectly through these primary reinforcements, they can become reinforcers as well. But it becomes more subtle when you think about social reinforcements. Hugs and smiles, words of approval, attention can also work as reinforcements. People will do work in order to be in a social situation. Being in a prison devoid of social contact is quite punishing. Chimpanzees, they will work, they will do something in order to get a glimpse of another person. And now the controversial bit is some behaviors might not serve any need whatsoever. It's unclear what's driving a person, or let's say an animal, to do certain things. Can we really explain it in terms of reinforcement? Or is there something like intrinsic motivation? Why is it that some people in the 18th, 19th century went to the North Pole on these crazy expeditions to find out why the North Pole is? There was certainly no food there. There was no warmth there. All the primary reinforcements worked in the opposite direction. And still people go on these crazy exploration adventures. For what reason? And some researchers believe that there's just intrinsic motivation. It works just very different than operant conditioning. Maybe there's different processes at play here. And other researchers believe, well, intrinsic motivation, it's still related to reinforcement learning. Because maybe you're just learning information, you're still, it's still linked in some way. So the behavior that people learn can be subtle, and you have to be very careful when you try to encourage children to do the right things and to avoid bad things like temper tantrums. You have to be very careful with how you reinforce kids, because even your attention can be a powerful motivator. So I want to show you this funny video of this kid that's a little bit out of control, but he seems to elicit his temper tantrums under the right or under very special circumstances. All right, this goes on and on and on. So the parent has reinforced this temper tantrum at some point just by paying attention to it. Now, when you work with children or you're a parent, you know this, and you know you shouldn't reward kids for bad behavior, but it's so difficult sometimes. You're in a store and your kid is not behaving well, and you do anything for the kid to just behave, and therefore you give them some piece of food, some candy, let's say, and then they learn something very important, like, I can display this temper tantrum again to get attention. All right. So now we'll switch and talk about some issues, some problems with these behaviorist theories. So the question is, is all learning driven by just reinforcement? And nowadays we know that there are things you learn without reinforcement. There are mental representations that you learn no matter if a reward is present or not. There are also biological predispositions where some associations are more natural to learn than others. Learning is not universal across species. Certain species find certain associations more easy to learn than others. Also, some learning can be one trial. One trial is enough to establish an association. For other associations, it's more gradual. And finally, there's observational learning, where no reward or consequence is needed for learning. You just observe somebody else doing it. So one piece of evidence for animals learning things about the environment that does not seem to be driven by reinforcement is research by Edward Tolman. So he placed animals in these puzzle boxes, these mazes, where animals had to figure out sort of the right sequence of doors and curtains to go through to reach the end state, which could be a food box, where food was either present or not. And he found, not surprisingly, this is just very simple Thorndike gradual learning curves again, that over time errors go down, like the number of wrong turns that these, I think, rats are taking in these mazes. But what's interesting is that even if there was no food given to these rats, there was still learning over time. The errors are going down when there's no consequence at all. Now, if there is food given, these animals learn a little bit more quickly. Now, in this particular condition, the food was delivered not for the first 10 days of learning, but after the 11th day. And you can see here that under this condition, learning goes very quick at this point in time. But again, there's a whole bunch of learning that takes place in the absence of any specific food reward. So what's going on here? We have to assume that the rats are learning some mental representation of their environment. They're learning some cognitive map that helps them to navigate these environments. And this goes against the law of effect that Thorndike proposed, because they are learning associations or representations without any sort of reward from the environment. This is just internal representations developing just because the animal wants to or is inclined to do so. So here's another example of animals learning cognitive maps. If you place an animal in this very simple, non-maze-like situation where they just start at this point and they have to only learn that they just have to go straight ahead through these sets of corridors to receive some food, then they will display very interesting generalization behavior, where in this new maze, if you block the entry that was previously leading to the food, the animals don't go to the nearby walkways, like 9 and 10, which would be predicted by sort of classical operant conditioning, that they would generalize. They actually go to number 5. And the reason is that this way, number 5, is in the right direction of the food. And the only way the animal can know what the direction of the food is if they've learned some mental map, some cognitive map, where they realize if I'm here, I need to go, I'm roughly going in this direction ultimately to the food. So learning is much more complicated than just learning associations between sort of parts of these walkways and the eventual delivery of food. The other potential problem for very general learning theories that behaviorists claim to apply to all species, is that there are certain things that animals can easily learn and others with great difficulty. So birds can easily associate illness with visual cues, but not with taste, because it's very natural for birds to pick out food based on visual cues. Rats, on the other hand, they will associate illness with taste, but not with visual cues, because rats just have just a very different biological predispositions. So this is a very clever experiment by Garcia that shows how some associations are just more naturally learned than others. So in this experiment, a rat is given sweetened water. It's given some light stimulus and some sound stimulus. So these are 3 conditioned stimuli. And then they're also given 2 unconditioned stimuli, either a shock. So one group of rats gets the shock, the other group of rats gets the illness. And now the rat has to figure out, in some sense, what has caused the shock or what has caused the illness. So if we believe the sort of standard laws of classical conditioning, then all these three stimuli could be associated with the shock or the illness. But that's not what rats learn. And how do you know this? Because we put these rats in new situations, and then we see what their behavior is like. So if the rat was made ill, and you give them sweetened water, they will avoid the situation. Because the rat naturally has learned to associate the sweetened water with illness. So that's not surprising. But when the rat has been made ill, and you now give it unsweetened water, it will be happily drinking that water, even if you're presenting these light and sound stimuli at the same time. So that's surprising because the light and sound could have been associated with the illness, but the rat refuses to learn that association. On the other hand, the rats that were shocked in the presence of light and sound, they will avoid light and sound because they learned that association, but they happily drink the sweetened water if the light and sound is not there, because they've not learned the association between sweetened water and shock. So this, the experiment seems complicated, but the conclusion is very simple. That for a rat, it's very natural to associate illness with the taste of water. It's very natural to associate the shock with the light and sound. But learning these other associations is less natural, and the rat will simply not learn it. And Garcia argued that animals are these biased learning machines. So evolution is basically informing these rats that some association is just more natural, more important than others. And so we have to think about the evolutionary background of these animals to understand what they will eventually learn. Now, one more type of learning, observational learning. Again, this is an example of learning that presents a problem for the standard behaviorist theories that focus on the role of reinforcement. So many animals, they can learn by example without any reinforcement. Monkeys can watch another monkey receiving a reward or be punished or exhibit a fearful response, and other monkeys will learn from that. And this is called vicarious conditioning. This relates to your question earlier. Monkeys can learn by observing what other monkeys are doing. Infants can learn to imitate adults. So infants, just when they're just born, they learn to imitate their parent, just sticking out your tongue, which is an amazing behavior. Think about all the cognitive machinery that's needed to do this. You need to recognize that a tongue is a tongue, and I have my tongue of my own, and this is how I need to, what I need to do to mimic this behavior. So clearly we learn by imitation, and this can be good when we are learning sort of desirable, when we're copying desirable behaviors, but this can also be very bad if we are copying undesirable behaviors. So Bandura has studied how kids are learning to imitate adults. And his experiments have far-reaching consequences for how we think about the influence of media and the influence of adults on children. So he did these experiments called the Bobo doll experiments, where an adult is in a room and the adult is interacting with this Bobo doll. It's this plastic inflatable doll that just can move back and forth. And as you'll see, the adult will display some aggressive behavior towards this doll. And there's some 4-year-old kids in this room that are observing this behavior. And then Bandura was interested in what the kids will do after seeing this adult in action.
The model come over the doll with an island, flung it in the air, repeatedly. Threw it down and beat it.
So these kids saw that behavior, right?
The room contained varied play materials. The children could choose to play aggressively or non-aggressively. The children devised new ways of hitting the doll. Now the object of interest was the novel aggressive acts, not punching the doll. The children in the control group who had no exposure to the aggressive object never exhibited the novel forms of aggression. Here's a creative embellishment that always has the weapon of assault.
Right. So an interesting part of the experiment was that if another adult entered the room, when the first adult was showing this aggressive behavior towards the Bobo doll, and then another adult came in the room and said, "That's not appropriate, you should not display this behavior," then the children who watched this whole exchange were not as aggressive as when the adult came and the second adult came in the room and said, "Oh, that's great what you're doing, please continue." So children not only watch that person who's doing the thing, it's also watching adults interacting with each other and seeing if there's approval or disapproval. Now the big issue here, of course, is can this explain how aggressive behavior in children, if that's caused by violence in the media or violence in the environment in general? Most of the evidence points to a causal effect here, where exposure to violence in the media causes violent behavior in children. But there are some, you have to be very careful with these interpretations, because it could also be just a mere correlation. It's possible that sometimes the children that tend to be violent or aggressive to begin with, they seek out violent games or violent television programs. So it's one thing to show in the lab that there's a causal connection. It's quite another thing to show in the real world if there's a causal connection between media violence and violence in kids. But the preponderance of the evidence shows that there's a causal connection. We just have to be very careful. All right, so that's it for today. I'll see you next week.